Okay, let's do a goodness of fit test using the chi-square distribution. And goodness of fit means we are given a proposed distribution and we're supposed to see if some observed values from a population that we have access to fits that distribution. So in this case, here's a problem. We have the office handbook and it lists 4 major reasons that people are late for work: traffic, sleeping through the alarm, coffee spill, and alien abduction. And it gives us the percentages that people are late for work because of these reasons: 40% for traffic, 30% for sleeping through the alarm, and so on. Now, we take a poll of 50 people at our office, and we find that 27 of them, just over half, were late for work because of traffic, 16 slept through the alarm, 6 people had a coffee spill, and 1 person was abducted by aliens, and hopefully that adds up to 50. So 27 plus 16 is 43, plus 6 is 49, plus 1 is 50. That works out nicely. And we want to see whether our office fits this distribution that was in the office handbook. So we want to do this. We want to test that hypothesis at the 5% significance level. Before we do anything else, let's compute the expected values based on the distribution that we were given. So according to the office handbook, 40% of people should be late because of traffic. So 40% of 50 is 0.4 times 50, and that equals 20. So we would expect 20 people to be late because of traffic. Actually, in our survey, 27 were. 30% of 50, 0.3 times 50 is 15. And 0.2 times 50 is 10, and 0.1 times 50 is 5, and 20 plus 15 is 35, plus 10 is 45, plus 5 is 50. This should add up to 50 also, which it does. Once we do that, we can write down our null and our alternate hypothesis. Our null hypothesis is going to be that our observed data fits, so our office fits the handbook, and the alternate hypothesis, H1, is going to be that our office does not fit the handbook. The next thing we want to do is compute our chi-squared statistic. We do this just like we did in the previous section. So our chi-squared statistic is just the sum over all 4 categories of the observed value minus the expected value squared divided by the expected value. So in this case, we have, for the first category, the observed value is 27. That's how many people were actually late to work because of traffic. The expected value was 20, and we put that over 20. In the second category, we have 16 minus 15, all over 15. In the third category, we have 6 minus 10, all over 10. And in the fourth category, we have 1 minus 5, all over 5. We're going to put that into our calculator now and do a computation. And if I've done it correctly, I think we get 7.32. Next, we have to find the p-value. To do that, we're going to use our chi-square table. And if we want to use our chi-square table, we need a number of degrees of freedom. So degrees of freedom, when we're doing goodness of fit test, is just the number of categories. So k is the number of categories, 1, 2, 3, 4 categories, minus 1. So in this case, it's 4 minus 1, or 3. We're going to be using the third row of our table, the one labeled 3. We have our chi-squared value of 7.32. We look across the third row of the table and see that 7.32 is bigger than 6.25, but smaller than 7.81. Those are 2 values that are in the third row of our chi-squared table. And so the p-value, we look up to the top, our p-value is definitely bigger than 0.05 and definitely smaller than 0.1, which are the 2 values at the top of the table, 0.050 in the table, 0.100 in the table. So the p-value is bigger than 5% and smaller than 10%. Our alpha is 5%. So now we're going to compare our p-value to our alpha. So our alpha is 0.05. Our p-value is definitely bigger than that. Though not by much, but it's bigger. So our p-value is bigger than alpha. P-value is bigger than 0.05, and alpha equals 0.05. So our p-value is bigger than alpha. And we know that when our p-value is bigger than alpha, we do not reject our null hypothesis. So in other words, the data that we collected from 50 people does not give us sufficient reason to reject the distribution that we were given in the office. Not at the 5% level, it doesn't. Although we can see that the aliens are definitely underperforming in our office.